Okay, so Cramer's rule, you've got to get, this could be, it's a way of calculating your linear equations. So, for example, this could just as easily be 2x equals negative 4y plus 4. And then you basically be solving for x and y. And here, though, we're just solving for x1 and x2, right? So I'm going to write this as 2x1. And I'm going to take the x2 to the other side, which is the other thing that we have to solve. So it'll be plus 4. And then there'll be x2 that we have to solve equals 4. So that's the first equation. And then the second equation is 3x1 plus 7x2 equals 6. Now, if we wanted to solve this simultaneously, we could just times this by 3 and this by 2, and we would get 6x1 plus 4x2 and 6x1 plus 14x2 equals, and then that'll be 12, and this will be 12. And then you subtract them from each other, and then you are able to solve. The Cramer's rule just uses, it's sort of an introduction to matrices, where it you turn these into matrices. So let's have a look. So we have to set the equations up nicely. Okay. So then we will look at the formula. So these are basically just numbers. So this is, we could say, is A1. This we could just call A2. Then this one here, we would call B1, and this could be then B2. And this, I'm marking these because of the formula that you have to use for Cramer's rule. So Cramer's rule is just using the same formula each time. And let's call this one then C1 and this one C2. Okay. Okay, so this is basically just you're giving the coefficient of each of these terms you're assigning them a value. And then what you can say is, as part of the formula, is to say then this x1 is equal to, let me say, x over d, and x2 is equal to the x2 over d. Okay, now what is d? So then we use formula d equals And now we're going to say it's this is now what we call a matrix, a 4x4 matrices. Where the first one is just A1, and then the bottom one will be A2, and then B1, and then B2. So basically what you do is you say D equals the matrices, and then you turn the thing I've highlighted in yellow, the coefficient, and you mark all those off. So what does that equal? Well, A1 is 2, right? So you say A1, and the you work out your determinant is you cross multiply. So it's the different color, that times that, and that times that. So it's basically, we have to say A1 times B2 equals, minus B1. Well, we can say B1 times the other one, A2. Let me do it this way. I'll say A2 B1. So it's yellow, yellow, blue, blue. So you cross multiply these to get the determinant, and then let's see what that is. So A1 is 2, right? So I'm just going to write that on. So it'll be 2 times, and then the B2 is 7, minus A2, which is 3, times the B1, which is 4. And then I get an answer. So it'll be 14 minus 12, which is 2. So the D is 2 for the first one. 2. Wait, what did I use? Yeah. Okay. Okay, so D is 2. So let's just highlight that. Okay, now I do my next matrices, which is so I've done this, I'll do this in pink. I've done that matrix. Now I'm going to do this matrix here. Okay, so that's going to be dx2. Right? Okay, so dx1 will be these two, dx1 will be these two. So, and matrix. Okay, so that will be C1 and C2. Start with C1 and C2. And cross multiply. B1, the blue ones. So we've done yellow and blue. Now we're doing green and blue. 1, 2. And again, we just cross multiply. So it'll be, so C1 is 4. Times 6. Sorry, no, not 6. It's C1 times B2, so it'll be times 7 minus 7 and then 6 times 4. The 4 times 7 is 28, and 6 times 4 is 4. So dx will be 4. Okay, so that should give us, let me just check the answers, because we can actually check these answers. So if I times this by 3 and this by 2, I get them both to be 6x1 and 6x1. So if I subtract them, and then this one we times by 3, so that's 12x2. And then this one times it, so 12 and 14. So 12 minus is minus 2, and then this would be times 5. So this would be minus 2 here. And this would have been times by 3, which would give us 12, and this would times by 2 would give us 0. Should get the 1 to be 0, that's weird. Double check that. Yeah. Okay. Times by 2. These go away. But that does make sense, because then 2x would be x1 would be 2. Yeah, so it actually is right. So dx1, so let's actually do x1 to show it. So we see this formula here. Once we've done this, then we use this formula here for our x1, right? So x1 equals, so dx1 is 4. And our d is 2. If you take from there, and we get x1 to be 2, which actually does work. X1 equals 2. Because when we times the 2, we times this one by 3. Well, I don't know if I need to do the kind of the proof, but it does actually work. Because if you make this 2 times 2 is 4. Now we actually end up getting x2 to be 0 when this happens. And we can probably go and do that for the rest of the space. So we can see that x1 is equal to 2 when we do this, because dx is 4. If we put that there, we get 4, and if we put our d there, we get 4 over 2, which is 2. So let's just remember that we got dx1, we got x1 to equal 2, because I want to just use a bit of space there. So we've got x1 to equal 2. Let's just make a note there. So because we can check it later. Now let's do dx2. We don't actually need to do it, but it is for 5 marks. That's what we actually do. Okay, so what's our x2 matrices going to do? So you see we've done yellow and blue, green and blue. So the next one must be, what we haven't done is orange and green. We've done yellow, blue, green, blue. We haven't done yellow, green. So this will give us our x2. So x2 is going to be yellow, green. So I'm not going to do the whole thing because I'm not going to do this A1, B1, A2, B2, C1, B1, C2, B2. What I'm going to do is just say, okay, it's the yellow and the green. So let's just put them straight in. So 2 and 3. This is what you're going to be doing in the exam. You don't want to have to write the formula each time. So 2, 3, and then 4, 6. And that's going to equal 2 times 6. So I went too slower and now I'm going through a bit faster. 2 times 6 minus 3 times 4. And that's going to be that's going to give us 0, which is correct. And I do this. Now, I've got the 3 things. So that's Cramer's rule, it's getting these 3 things. So the dx2 is 0. Well, when we put in that, 0 over 2 is going to give us 0. So our x2 is equal to 0 over 2, which is 0. Okay, and that's basically x1. So x1 is 2 and x2 is 2. And if we sub that in, that'll work, right? So I'm going to just sub it in. So everywhere I see an x2, I'm going to put a 0. So 0 and 0. Because 7 times 0. And so 2 times x1, which is 2. 2 times 2 is 4. That's right. And 3 times 2 is 6. So it works. What I think we can do is maybe just try and just go over that one more time. Sort of maybe just doing it a little bit more and not getting too worried about the A1, B1, B2, B2, and let's just go over what we did. So Cramer's rule says that x1 is equal to dx over d, and x2 is equal to dx2 over d. Now this represents when we do the values into a matrix and then we cross multiply them. So what do we mean by, and then the discriminant is the first thing we do. Now the discriminant is when we take the numbers that are in front of our x1 and x2. So we always have to get it into this notation. Something x1 plus something x2 equals something. And then the other one, something x1 times something x2 equals another something. And so because you have 2 equations, you can solve them simultaneously. But in this case, we're doing Cramer's rule. So let's look at what we do. We take the number in front of the x1 and we put it here. Then we take the number in front of the x1 in the second equation and we put it there. And then we take the number in front of the x2, see? And we put it there. Okay, so those get put there and there. So in this case, it was 2, 3, 4, 7. And what we do is we cross multiply. So if I was to skip this whole thing of doing that, all I'm doing is I'm saying 2 times 7 minus 3 times 4. And that's it. 2 times 7 minus 3 times 4. And that's how we get the thing that goes at the bottom. So I've written up this whole thing in colors for you to kind of go over one example like in your exam and just go through slowly. And then it should be quicker as you do it each time. So where you don't have to do this. So 2 times 7 is 14. 3 times 4 is 12. And so what I'm doing is I'm saying, again, 2 times 7, 3 times 4 is 12, and that goes over there. I'm sorry, and then I minus those from each other. So 2 times 7 is 14, 3 times 4 is 12, minus them from each other, 14 minus 12 is 2, and that's how I get the 2. That's how I get this to be 2. And then to get the next one, to get my x1, I do the x2 and the c1, right? So I say 4 times 6 is 24, 7 times 4 is 28, and then I minus those from each other, and I get 2. 7 times 4 is 28, 4 times 6 is 24, so minus them 4 times 7, 6 times 4, and I get 4, and so that's how I get that. So that times that, 7 times 4 is 28, 4 times 6 is 24, minus those from each other, and that's how I get my 2. That's how I get my x1. So that's how I got this 4. So it was that times that minus that times that, and that's how I got the 4. Now to get the x2, I do the x1s. And I do the things in front of the x1s and the things in front of the c1s. So that was 2 times 6 is 12, 3 times 4 is 12, minus those from each other, and that's how I got my x2 to be 0. So this was 4, and my x2 was, again, 2 times 6, so 2 times 6, 3 times 4 was 12, minus those from each other, and I get 0. 0 over 2 is 0, and that's how I got my x2 to be 0 and my x1 to be 4 over 2, which is 2. Okay. Well, I've got 7 minutes left. I'm going to do that one more time. Without the formulas and just looking at it visually. See if we can try one more time. Okay, so we've got the colors, the yellow, the blue, the green, and we want to get, let's start off by getting the D, because the D is the thing at the bottom. So to get the D, we are going to use the numbers in front of our x1 and our x2. Okay, so that was 2 times 7. And then we're going to minus 3 times 4. That's how I get my D. So I'm doing exactly the same thing. I'm just trying not to do formulas to confuse, but rather to do, so 2 times 7 is 14. 2 times 7 is 14. 3 times 4 is 2. And that's how I get my D. So that's how I get my 2. And so that is the D that goes there and there. Okay. Now to get my x1, I use all the coefficients that aren't in front of x1. So I'm using because x1 has a yellow, I'm using not the yellow, I'm using the blue and the green. So I say 7 times 4. 7 times 4 is 28, and then my so 7 times 4 and then 4 times 6. So it's just cross. 7 times 4 and 4 times. Let's do that. 4 times 6. 4 times 6. And then we minus them from each other. 7 times 4 is 28. 4 times 6 is 24. 24 minus 4 is, so that's my dx, right? So dx. You just put in here that this is my d. And then this is the dx. And 7 times 4 is 28. 4 times 6 is 24. 28 minus 24 is 4. And that's how I get my dx to be 4 there. And that's that value here. That. And then my d, let's do my dx2. Okay, and so if I'm wanting x2, the one was dx1. If I'm wanting my x2, I do the numbers that aren't in front of the x2s. So that's the 2 and the 6 and the 3 and the 4. Okay, so dx2 equals 4 times 6 and 7. X2, sorry, x2 is the number in front of the x2 is where I use the numbers that aren't in front of the x2. Sorry, so it's 2 and 6. It shouldn't have been that. Because x2 had the light blue, so we're not using light blue because we need to solve x2, so we use the numbers that aren't in front of the x2. So that's the yellow and the green. So 2 times 6, because then we're cross multiplying, right? 2 times 6 and 3 times 4. That's how we get our x2. Minus 3 times 4. And that gives us 0. And now that we have that, then it's easy, right? So it's because I just get my x1 using these things. So x1 equals dx, which is 4, over d, which is 2. So I'm basically repeating myself, but I'm just not using the, I'm not showing the matrices that I drew. And then x2, 0 over 2, which is 0. So x1 equals 2 and x2 equals 0. Okay, so that's Cramer's rule. I'll upload that video and you can watch it again. And then what I would suggest is taking a past paper and just seeing if you can do the same with the simultaneous equations. And if you do 4, I think you'll have the hang of it. And then it gets boring, then you know you've got it. Okay, so I'm going to stop it there. And then I'll send a meeting with a new link.